Watch the token counter, 12,000 tokens, 40,000, 90,000. The agent is still answering. It's still confident. And it's getting worse. Rereading a file it already read, redeciding something you settled 40 minutes ago. Here's the part that matters. It has room left. The window isn't full. It didn't run out of memory. It got confused first. Those are different failures. And almost everyone debugs the wrong one. So this video is about what actually happens to an agent's memory over a long session. 4 ways every serious agent framework compresses your conversation. And I'll show you all 4 chewing through the same transcript, what each one throws away. And then the part I'm going to earn. There's a category error underneath all of this. Most teams reach for the wrong tool because they've misdiagnosed the problem. That one lands about halfway in. Working memory first. You know this layer, so I'll be quick. Everything the model can see on this turn. The system prompt, the conversation so far, whatever files got loaded, and every tool result that came back. That's it. That's the whole working memory. It is not a database. It is not persistent. It's one long string of tokens that you rebuild and resend on every single turn. Session ends, the string is gone. There is no it remembers. There's only what you put back in the string next time. Everything in this video is about the fight for room in that string. Now, if the string just filled up, this would be an easy problem. It doesn't fill up. It rots. Chroma ran this properly in July 2025. 18 models GPT 4.1, Claude 4, Gemini 2.5, Qwen 3. Same task. Same answer sitting in the context. All they changed was how much text surrounded it. Performance degraded as the input got longer. Not at the limit, along the way. And it happened on tasks that aren't even hard. Copy this text back to me. That's the task. Add one plausible but wrong distractor and it gets worse. Add 4 and it gets worse again. The result that should bother you is this one. They fed the models about 300 tokens of just the relevant part, then the full 113,000 token conversation. Same information present in both. The full version scored worse. Not slower. Worse. Why? Because attention is a budget. And it's a hard one. Anthropic's own context engineering guidance says it plainly. Models have an attention budget they draw on when parsing large volumes of context, and context has to be treated as a finite resource with diminishing marginal returns. The reason is architectural. In a transformer, every token can attend to every other token. N tokens means n squared pairwise relationships. That budget gets spread thinner across every token you add. So every token you add isn't free. It's paid for out of the attention available to everything else, including the instruction that actually matters. So, you have a transcript, it's getting long, and long is expensive, in a way that isn't just money. Here's the transcript. 1 bar, left is the oldest turn, right is now. There are 4 ways to make this bar fit. Every framework you use runs some blend of them. Watch what each one does to the same bar. 1. Truncation, the sliding window, keep the last 10 turns, drop everything older, it's a queue. This is the default in more production systems than anyone admits, and it has exactly one virtue. It costs nothing. No model call, no latency, completely predictable. And it's catastrophic in a very specific way. It drops by position, not by importance. The oldest turn in a coding session is very often the most important one. It's where you said what you're building and why. So the agent forgets the goal and keeps the last 4 tool calls, the session that confidently finishes the wrong task. 2. Summarization, compaction. Anthropic's definition is the clearest one out there. Take a conversation nearing the context window limit, summarize its contents, and reinitialize a new context window with the summary. Notice what that actually is. It's a model call. You are asking the model to decide what mattered. Done well, it keeps architectural decisions, unresolved bugs, and implementation details, and throws away redundant tool outputs. Done badly, it keeps a fluent paragraph and loses the one path you spent 20 minutes on, and it compounds. Summarize a summary of a summary, and you get drift, not deletion drift. Details sanded off a little at a time, until the agent is working from a plausible story about your codebase instead of your codebase. Now the one that actually survives the session. Structured state anthropic calls it structured note-taking. Instead of compressing prose into more prose, you write the durable facts out into a fixed shape, a JSON object, a file, progress.md, task, decisions made, files touched, open questions. The difference is that this shape doesn't drift because it isn't being rewritten each time. It's being updated. A field either has a value or it doesn't. And because it lives outside the window, it's still there tomorrow. It's the only one of the four you can say that about. The cost is that you had to know in advance what was worth a field. Anything you didn't model, you don't keep. And the fourth one doesn't compress anything at all. Retrieval. Don't keep the history in the window. Put it in a store and at each turn pull back only the pieces that match what's being asked right now. The bar barely moves. Most of it stays on disk, small windows, and it scales past any conversation length because you're never holding the conversation. And it has a failure mode the other three don't have. The other three lose things by compressing them. Retrieval loses things by not looking for them. If the query doesn't surface the turn where you changed your mind, that turn is functionally deleted. While sitting right there in the database, same transcript, 4 passes, truncation cuts by position, compaction rewrites into prose, structured state extracts into fields, retrieval leaves it alone and queries it. Now watch one fact move through all 4. Turn 9. You changed your mind. Actually, use a token bucket, not a fixed window. Truncation drops it. It's old. That's the entire test it applies. Compaction keeps it in pass 1. By pass 4, it's been smoothed into discussed rate limiting approaches. Technically true, useless. Structured state has it cleanly and forever. But only because somebody thought to give decisions a field. If they hadn't, it was never written down at all. Retrieval has it perfectly preserved and will not hand it back unless your query happens to mention buckets, ask how should I limit this endpoint, and you get the fixed window turn. The one you reversed. One fact, 4 different ways to lose it. Look at what's gray. That's what the model no longer has. Every one of them is lossy. There's no fifth option where you keep everything because keeping everything is the thing we just measured as worse. So the real question was never which compression is best. It's what you can afford to lose. Which brings me to the thing this whole video has been walking toward. Watch what teams do when an agent starts forgetting, they reach for a vector database. And it feels right. Forgetting is a memory problem. Memory problems are retrieval problems. Retrieval is a solved thing. Embed it, index it, search it, ship. It does not fix the session degrading in front of you. Here's why. Retrieval answers, where is this? You have a large corpus, you need the relevant part, similarity search finds it, that's a search problem. What's breaking in a long session is a different shape entirely. Everything is already here, nothing is lost. Nothing needs finding. The problem is that all of it is competing for the same finite attention budget and the model is spending it on a tool result from 40 turns ago instead of on your last instruction. That's not a search problem. That's a budget problem. And budget problems have budget solutions. Compression make each item cost fewer tokens. Prioritization decide what gets to be in the room at all. Eviction decide what leaves. Retrieval is one tactic inside prioritization. It is not the category. Treat a context budget problem as a retrieval problem and you build a beautiful semantic index that stuffs 6 more chunks into a window that was already over budget. You made it worse. Precisely, expensively worse. Now, let me undercut the thing. I just sold you. Everything so far points at one fix. Stop keeping it all, keep the right things, compress, prioritize, evict. There's a failure mode inside that which is worse than forgetting. A model that has forgotten something behaves like a model that doesn't know. It hedges, it asks, it rereads the file. Annoying and honest. A model handed a wrong memory does none of that. It's been told by a trusted channel that this is a fact. So it proceeds. Confidently, on a decision you reversed an hour ago that got extracted, stored, and faithfully injected at the top of every future session. Forgetting is noisy. Wrong memory is silent. So the moment you add a memory layer, you've taken on a second job. Not just storing facts, invalidating them. Deciding when something stored stops being true. Almost nobody builds that part. It's why memory systems fail slowly instead of loudly. So if wrong memory is the danger, it's worth knowing exactly where it gets built, because every stage below is a place one can enter. 4 stages, nothing exotic. Extract. After a turn, or at the end of a session, a model pass reads the transcript and pulls out candidate facts, not the conversation statements. Prefers PyTest. Deploys on fly. Rejected the queue approach on March 3rd. A model decided each of those was worth keeping. A model can be wrong about that. Store. Each fact goes into a store vector, usually with metadata, that decides who can ever see it again. Scoped by user, by session, by agent. That scoping matters more than the embedding model does. A fact scoped to the wrong agent is a leak. It's the most common real bug in this whole design, and it never shows up in a demo. Retrieve. At the start of a session or before a turn, you query by semantic similarity against what's happening right now and take the top matches. Not everything about the user, the relevant part. Inject. Those facts get written into the context near the top, formatted as facts and not as dialogue before the model generates anything, which is also what makes them so easy to trust. 4 stages, that is the entire architecture that gets called agent memory. And notice what it is. It's the retrieval pattern. Same machinery, pointed somewhere else, not at the conversation you're inside, at the things that outlived it. 4 stages, and not one of them asks whether the fact is still true. Quick word on the number everyone quotes for this, because you are going to see the chart. Mem0 published 92.5 on LoCoMo, a long conversation memory benchmark at around 7,000 tokens per retrieval call, against full context approaches that routinely burn 25,000 plus, roughly a quarter of the tokens that part holds. The leaderboard position doesn't, it's a vendor scoring its own product. The 92.5 is measured against their own previous version rather than against full context. And a competing vendor has published a detailed rebuttal of the evaluation. Direction, solid. Which is worth naming properly, because memory is doing too much work as a word. The framework docs mostly agree on a split. Working memory is the window. This session, gone when it ends. Then 3 that persist. Semantic, facts and concepts. The user stack is Postgres and Elixir. Episodic, past events. Last time we tried this migration, it deadlocked. Procedural. The rules for doing things. Always run the linter before proposing a diff, which in practice is your system prompt. And the interesting version is one the agent updates itself. Here's the useful question. Most agents that feel like they have amnesia have working memory and nothing else. Most agents that feel rigid have procedural and no episodic. They follow the rules and learn nothing from what already went wrong. Which one is yours missing? So how do you tell which problem you actually got? There's a test, and it takes about a minute. Take the last thing your agent got wrong, then ask one question. Was the information in the window at the time? If it wasn't, it was in a file nobody opened, a doc nobody loaded, a session from last week, that's a retrieval problem. Go build the index. It will work. If it was in there, and the model walked straight past it, that's a budget problem. And an index makes it worse, because you just added 6 more things to walk past. Almost every long session failure is the second one. Almost every fix I see shipped is for the first one. That gap is the whole video. Back to the session from the beginning. Still answering, still confident, still getting worse, with room to spare. Now you can name it. It wasn't out of room. Its attention budget was spread thin across every token in there. And the instruction that mattered was one of thousands, weighted like all the rest. It was still in the window, it just wasn't winning anymore. Nothing was missing. So nothing could be found, which is exactly why adding a search layer wouldn't have touched it. The fix was never a bigger window. And it was never a better index. It was deciding on every turn what earns a place in the room. If that landed, subscribe. The next one goes inside compaction itself. What a summarization pass actually keeps tested against a real transcript, and how far it drifts by the 4th pass. And drop the one thing your agent keeps forgetting in the comments.